Hello, in this video I'm going to be going over rate law and various problems that go along with it. So right here is some rate data of this chemical equation, and I have three experiments. Each of them have varying degrees of concentrations of reactant 1 and reactant 2. And then it gives me the rate at which this reaction undergoes depending upon the concentrations. So a rate law is dependent upon concentration. It says find the order with respect to NO. First of all, I'm taking a step back. The rate equation is rate equals the rate constant times a concentration of reactant A to a power M times the concentration of reactant 2 to the power of N. And these powers are our orders, and they directly are affected by the concentration, or it's how the rate is affected by concentration. You have either zero order, first order, second order are the common ones. Alright, so what I have to do is, if I want to find the order of NO, I have to look at where my concentration doubles, but I have to pick it where my other reactant remains constant. Because if I pick it where my NO doubles and my O2 doubles, then when I'm looking at how my rate is changing, then I'm not really sure whether it's because of the change in concentration of NO or the change in concentration of O2. So I got to have one of them constant where it doesn't change. So I'm going to have O2 be constant, so that's experiment 1 to 2, and NO, the concentration doubles. So this doubling is going to impact this rate, and I have to see how many times does my rate double. And I'm looking for a calculator. It's right back here. Alright, so 0.041 times 2. 0.041 times 2. It doubled once. But I still haven't gotten to the 0.0164, so I'm going to times it by 2 a second time. And now I have 0.0164. So my order for NO is 2, because it took me 2 times of doubling to get from 0.0041 to 0.0164. Doing the similar thing for O2, I have to see where NO doesn't change. It's between experiment 1 and 3. It doesn't change at all. And O2 does. It doubles. So the impact of this O2 doubling, I have to then compare to my rate. If I take 0.0041 times it by 2, I'm going to get 0.0082. So I just doubled it once to get to where I want to get to. So O2 has an order of 1. Now it says find the overall order of the reaction. What you do is you add up your two orders. 2 plus 1 is 3. And write the rate expression. So rate is going to equal K times the concentration of NO to the power of 2, second order, times the concentration of O2 to the power of 1, first order. That is my rate expression. If I want to find the rate constant K, what I'm going to do is I have 3 possibilities, 3 ways of finding it. I could use my data from experiment 1, experiment 2, or experiment 3. I'm just going to pick experiment 1. So my rate in experiment 1 is 0.0041. And this equals my K that I'm looking for. And NO2 is 0.015 squared, and my O2 is 0.01 to the power of 1. 0.015 squared times 0.01 equals 0.1234525 and it's molarity cubed. Basically, I'm going to divide both sides by 0.0000225. Okay, point 0.0041 divided by 0.12345 gives me a K of 1822 and I'm not going to be real concerned on units. I'm not going to be taking points off, but technically if right here we're dealing with, we've got molarity per second, and here we got molarity cubed. What's happening is this molarity is canceling out, and really we have a unit of 1/2 times molarity squared, as this is a third order overall reaction. But as long as you have 1822, I'll accept that. That'll be perfectly fine for this. And in an IB chemistry, if you ever go that direction, you'll have to know the difference between the various units of K depending upon what order the reaction is. Alright, technically sig figs being really official. We got 2 digits, 2, 2, so it would really be 1800. But yeah. Letter E. Last one, we got determine rate when NO equals 0.03 and O2 equals 0.03. Determine the rate. Alright. So in this case we have different concentrations. We want to find the rate. We now have our K from problem D. So rate equals, I'm just going to plug in the 1822, times our NO, so our NO concentration of 0.03 to the power of 2, times our O2, 0.03 to the power of 1. 0.03 squared times 0.03 times 1822. My rate in this case is going to be 0.049 molars per second, and that would be my final answer. And that's how you do various rate law problems.